Hello, this is Jung-Bok Cho. Today I'm going to talk about mobile IP. The reason why I chose this topic is nowadays people constantly move around with their cell phone and laptops. I was very curious how we can keep track of our mobile devices, especially mobile IP addresses, and how those communicate with each other. So just to make sure, I got this topic from the book. If you check the page 241, mobile IP was introduced in the home-based approaches section. And then if you check the page 566, the references is in the bibliography. Before I talk about mobile IP, I need to talk about mobile home-based approaches. In the past, people used diverse flat naming methods like broadcasting, multicasting, forward pointers, and so on, but they had a lot of problems when it comes to large-scale network. Broadcasting or multicasting was difficult to implement efficiently in large-scale network. Not only network bandwidth was wasted by the request message, but also too many hosts were interrupted by request. Forward pointers had performance problems when it became the long chain. Also, it was pretty vulnerable to broken links. You can think of it as a linked list. If the middle point in the linked list got broken, you cannot reach to the end. To solve this problem, home-based approaches was released. The goal of the home-based was to support mobile entities in large-scale network, and how it works was pretty easy. Just let the home keep track of the entities, where the entity is. One of the most famous example of home-based approach is mobile IP. How it works is pretty easy. Entity's home address is registered at the naming service. It means your address and other person's address you want to reach are known to each other. Then home agent keeps track of current address of the entity. Home agent is an agent that stores information about mobile nodes whose permanent home address is in the home agent's network. Then the last one is entity updates the home about its current address. It means if you go to the different places, your mobile device will notify the home agent that I just moved to these places. There's one more important term that you need to know. It is care of address. Just think of it as a temporary address you will get if you're in the foreign network. This is an example of mobile IP version 4. Let's assume that a client wants to contact with you. Always, the client will contact with the home agent, and the home agent will check if you're currently in the home network or not. If you're in the home network, you can swiftly contact with the client. Otherwise, the home agent will start to find you. And then the home agent will contact with the foreign agent that manages a foreign network that you're currently located in. Then this foreign agent will give you a temporary address, which is care of address. And then foreign agent will give back the address to the home agent, then home agent will give back that data to the client node. Then finally, you guys can contact with each other. There were two problems in the mobile IP version 4. The first problem was IP version 4 did not provide larger scalability and faster mobility. The second problem was if this client wants to contact with you, once again, it doesn't contact directly. You need to go this step, this 1, 2, 3, 4, this step again, and again. So this problem is called triangle routing problem. And then to solve these kind of issues, mobile IP version 6 came out. There were 3 significant changes in mobile IP version 6. First, no need for an agent anymore. In IP version 4, foreign agent communicated instead of the mobile node. If foreign agent did not exist, each mobile entity needed to manage IP version 4 addressable by themselves, but it did not have enough address spaces. However, in IP version 6, mobile entity had enough address spaces to store. Therefore, IP version 6 node can create address by themselves. In other words, the mobile entity can create the care of address by itself. Second, routing optimization. In IP version 4, when client nodes want to contact with the host node again, it always needed to communicate with the home agent. which is the triangle routing problem. But in IP version 6, except for the first time, once the care of address got registered in both home agent and client's address, it doesn't need to go through this home agent again and again. And then the last one is no more issues about the ingress filtering. Ingress filtering is a technique used to ensure that incoming packets are actually from the network from which they claim to originate. Mobile IP version 4 had issues with the ingress filtering because the client node puts its home address as the source address of the packet. In mobile IP version 6, the client node puts the care of address as the source address, and having a home address destination option allowed the use of the care of address to be transparent over the IP layer. Following this improvement of technology, mobile IP version 6 provided more efficient and effective mobility of node, and then the connection between the nodes became much more smoother. But still, mobile IP version 6 had security issues. The first issue is related to the sending binding updates to home agent and client's nodes. For example, a hacker can claim that a certain mobile node is currently at a different location. Like I'm in Seattle right now, I can lie that I'm in Los Angeles. So if the home agent accepts such spoofing information, the mobile node might not get traffic destined to it. The second one is related to the home address option. It is a new routing header type, and then it is used for tethering headers in the payload packets. iSet home address option helps the use of care of address to be transparent over the IP layer. However, this function can be used for hackers to hide their information, hide their location. To protect from these kind of security issues, two alternatives came up. The first one is IPsec. It is a secure network protocol suite that authenticates and encrypts the packets of data to provide secure encrypted communication. More specifically, it is for securing mobility messages between mobile node and home agent. The second one is related with routability. It is just basic mechanism in mobile IP version 6. First, you're going to check if the home address can reach to the care of address, and then allow to send a message if it can. So it is usually used for the securing mobility messages between the client node and mobile node. Like this, mobile IP version 6 has improved a lot, but still has a room to fix. Then this is my references. Thank you.